Hello, everyone. I'm Nemanja, and I'm going to tell you a story about air gap jumping attacks today. So these kind of attacks are usually not the kind of attacks that are used for gaining monetary benefit, but rather these kind of attacks are used as a weapon in global cyber warfare. As a mean of protecting interests between of global geopolitical actors. So these attacks are quite obscure. They happen relatively rarely, and when they happen, they hit headlines. They are turned into plot for Hollywood movies. And the goal of this talk will be to actually, in the end, show you some new methods that might be exploited as we speak. So to start, I will explain the general attack scenario for these kind of attacks that doesn't differ a lot from normal average cyber attack on certain organizations. So it starts with an infection. One host or multiple hosts are infected initially. Then it expands through the network and collects data. And of course, that data has to be extracted and to exfiltrate that network. So the only difference is that these dark blue arrows here are actually air gaps. So physically separate systems that you have to, the air gap that you have to jump in order to achieve each of these steps. And what is also really interesting, because these attacks are mostly aimed against infrastructure or some systems that as a geopolitical actor you want to destroy or disable. On the other side, also one of the goals of the attack can be just to generate damage on the other side, which we will see in one of the examples. So we will just warm up with one simple example, Agent BTZ, that happened in 2008. So U.S. military network was infected, allegedly through a thumb drive that was dropped somewhere on the parking lot of a military base in the Middle East, and someone was curious to pick it up. I mean, apparently, according to the official story, someone was curious. He picked it up. He inserted that into the Windows machine, and we all remember what happens when we had like pirated disks with video games, and when you put it in your computer, it runs the author file. So it runs a script from the author file, and that way the computer was infected. So it propagated so that every other removable media that was inserted into the same computer would be infected with this malware, and this worm was highly contagious. That it took Pentagon actually 14 months to remove it from its networks, and apparently it led to the foundation of U.S. Cyber Command. And the data is extracted. You also know this file name, thumbs. In this case DB, but originally thumbs.db, it's Windows image cache, the annoying file that pops up every time you plug a USB stick, memory stick in a Windows computer. So this malware would remove that file and instead create thumbs.db that would collect the data from that infected machine and then write it on the removable media that was already infected, and that way the data would be exfiltrated from that network. Another interesting example is Stuxnet. You probably all know about that, so I will just try to be quick. You probably know that that was aimed to slow down Iranian nuclear program. So then the way the attackers managed to slow it down was they infected the network actually through the network of contractors. So because these systems were heavily air gapped, the way in was through a bunch of companies that worked in the Natanz nuclear facility. So their computers were infected by by exploiting multiple, back then some of them were also zero-day vulnerabilities back in 2010. And then once in, it would just spread around SCADA systems, also abusing some vulnerabilities that were present in WinCC and Step 7, software from Siemens. And in the end, they would just patch the code and patch the code that was meant for these PLCs that we see on the right. And that way, the attackers had full control over physical, or actually controlling the physical process that was done inside the nuclear facility. So they could have the CNC channel from their network through these certain steps to start to trigger the attack. So basically, the goal of the attack was to slow down the nuclear program. There were actually two waves of attack: one on the overpressure system and one on the centrifuge drive system. That and also what is really interesting in this malware, there was no kill switch. So basically, once the command to initiate one of these attacks was issued, there was basically no way of sending the message, okay, abort the attack. And it is really interesting because these are, of course, air gap attacks. So once you jump the air gap and issue the instruction to start the attack, you cannot expect that, oh no, I have second thoughts. I want to stop it now. So that kind of makes sense. Next example comes from Snowden papers that were leaked by Edward Snowden back in 2013. So this is from NSA's toy box. Cottonmouth. This is actually a hardware implant inside the cable, and Cottonmouth is the whole series of these hardware implants that were meant to communicate with each other and create kind of a mesh network. So they had to be physically inserted into the desired air gap system in order to successfully reach the final goal. And it is really interesting that there is an open source project that is kind of replicating the functionality of this implant. Okay, this is just the same thing, just inside the USB plug. And yeah, also this is how it should look like once it's inside on the board actually soldered. And it is really interesting. When I was preparing this presentation, I found a typo in one of their documents. So apparently, when they were talking about Cottonmouth 3, they just copied and pasted the first paragraph from Cottonmouth 1. Now, the newest example comes from the CIA Vault 7 leak that was published on WikiLeaks website. So Brutal Kangaroo is the tool that was apparently used for jumping the air gap when needed. So it is consisted of 4 sub-modules, each of them having their own purpose for each of the steps that we described earlier. So basically, the infection vector can be like either just planting an exe file on a USB stick and waiting for the victim to initiate to actually start executing that file. So that's the first one, like manual execution. And there are also 3 other means of automatically executing the malware once the USB stick is plugged into the air-gapped computer. So, and this tool, Shattered Assurance, would make sure that every new thumb drive gets infected. That tool is running on the victim machine, right? And the main resistance mechanism is called Shadow, and Broken Promise is the processor, like for processing the data that is retrieved from infected thumb drives when the data is propagated back towards the attacker. And there is also a nice document showing how the graphical user interface of one of the programs for for setting up the persistence mechanism, so you can put your favorite pizza topping on on the malware. Okay, now I'm gonna tell you something how things work in an academic world. So in academic world, usually research papers are not focused usually are not focused on ways of exploiting the system, but rather how to create CNC channel and how to extract the data from the network, and that can be achieved by either when so CNC channel is usually achieved by machine, the air-gapped machine having some kind of sensors, and then inducing some physical signal that would then be picked up by that sensor from an infected air-gapped machine to issue a command, or to extract the data. Some kinds of physical emanations and emissions are used. So the first and basic cover channel will be definitely like radio, electromagnetic. And I will start with an example from 1945. So this is how this device here is called the Thing. It's a passive bug that was planted inside the US seal, inside the US embassy in Moscow, and it spent like 7 years there. It was created by Leon Theremin. You probably heard of him. He's the guy behind this amazing electronic musical instrument. And what was this bug was doing? It was completely passive. So the idea was that it was illuminated with 330 megahertz signal, and then it would reflect the audio data that was picked by a microphone inside the seal. And it was amazing. Like for 7 years, it was not discovered. And fast forward. In documents leaked by Edward Snowden, we see the similar system that uses continuous wave radar and to radiate, to illuminate a planted bug that is completely passive, and then that bug reflects back the desired signal, whether it can be either video signal or digital signal. And there is a very nice talk at FOSDEM 2016 by Jean-Michel Fried. You can look it up on this link, where he actually made like proof of concept for this kind of system and how easy it is for other people to make it. On the other hand, in 1985 there was a paper about like listening to emanations from CRT screen and being able to reconstruct the information that is being presented on the screen. It's called Van Eyck freaking, and that is completely so you don't need to plant a bug inside that TV in order to remotely see what's happening on the screen. It is just like pure electromagnetic emanations, and the similar principle was used by Mordecai Guri and his research group from the Ben Gurion University. I don't know where that is exactly. In Israel, but I forgot the name of the place. And you will see that name on next couple of slides, because his research group is quite fruitful when it comes to these papers. So basically, they were using existing buses inside the computers to actually generate these emanations by sending some just bunch of data and on the bus in order to induce an emanation that can be later picked up by other means from certain distance by an attacker. Then acoustic emanations. These are also quite interesting. This paper is meant to describe how to reconstruct, how to actually extract 4096 bits of RSA key just by pointing your smartphone onto someone's computer fan. And this paper is really amazing. I suggest whoever is interested to read that. So they were actually able to just by having the computer encrypting chosen plain text, that they could within like I think hour or two, I can't remember the exact time, but extract the 4096-bit RSA key, which is truly amazing. Another example for acoustic cover channel is bad bias, but I cannot tell you much about that because I couldn't find any malware sample, and it's talking about bad bias is probably a bit like talking about God. Like, some people believe in it, some people don't. I mean, some people prove that there might be possibility of that happening, but we don't know what exactly happened to Dragos Ruiu when he said that he was attacked by a malware that was apparently sending exchanging information between two computers via acoustic channel. But this was proved to be actually possible by Hansbach and Goetz, probably a year after bad bias was first mentioned, and they actually proved that it is possible to create kind of a mesh network of computers that could use speakers and microphones to communicate together and then exfiltrate data from the infected network. Then thermal. Well, these kind of emanations are really slow because temperature, of course, cannot change as fast as sound or radio waves. So, but still, there are some interesting papers, again by Guri and Murdoch, on how to use these channels to bridge the air gap. Also, this third paper is from the same group as the second one. So they were, but that's the other. So that's by cooling down or like using the AC unit rather than just creating a CPU load on certain machine in order to create temperature that will be read by another machine or another another machine, like that can be picked up by some other temperature sensor on the air gap network. And yeah, of course, light is probably the fastest cover channel. And there were papers describing how to use sensors on your laptops or phones for issuing CNC commands. And also this paper is from this year's DEF CON. Again, by Mordecai Guri, and they were showing how to use LEDs to exfiltrate data, and like flying a drone next to the building were really amazing. You can have a look at it. And also this paper is a bit older that talks about like how to use LEDs on keyboards because they are apparently controlled by the OS. They are not automatically turned on every time you press caps lock. So. Other cover channels can be seismic, like vibrator on the phone, or like magnetic by putting a large electromagnet next to some infected device. And these are all covered by Hassan's paper that you can have a look at. And now for the fun part, what are the future attack vectors? What can we expect to be used as an attack vector in the nearest future? So as you could see, like real-world examples extensively used USB-C as at least one minor attack vector. So USB just switched to a new version of the standard 3.1 that includes the new plug, and that is reversible. And also there are some other interesting lines there. And this standard basically wants to put a chip into everything. And it's really interesting from the hacking perspective. And and they also want to put a chip in a cable like this one. So what can we do? Can we make an evil cable? Well, luckily, there are not many engineers on the market that are very knowledgeable about this at the moment, and due to that fact, if you order some unnamed, unbranded cable or some USB-C device from Asia, you might get a device that uses an example that is provided by chip manufacturer, and that you can actually upgrade the firmware on it. So because it was meant to be reprogrammed and still like tested, and it's not meant to be definitely not meant to be sent to the end user. So these cables are so-called electronically marked cables, because this electronic marking stores information about for example, the maximum current that can go pass through the cable and other stuff. And this is how they look from the inside. So basically, there are versions that have two chips on both ends, and the way host communicates to these chips is through this newly introduced CC line, and by utilizing so-called SOP signaling. So and the speed is 300 kilobits per second. So this SOP signaling basically. If you send a packet with SOP prime or SOP double prime, it should not be interpreted by the machine by the device that is connected on the other side. It should only be interpreted by chips inside this cable. And standard also specifies so-called vendor-defined messages that are used for upgrading firmware in these cables, for example. So imagine malware manages to infect one of these cables. So we have one or two chips. What can it do? So usually firmware inside these chips is organized like this. There is a bootloader and two firmware banks, because you don't want to brick your cable. Like if it's upgrading and you unplug it, then it's completely useless. So what if you can use tools provided by these chip vendors to patch the firmware and use another bank for sending command and control and data information. And usually these are Cortex-M0 microcontrollers that, I mean, there are also some 8051 and some other exotic CPUs, but most of the time it's Cortex-M0. And they have between 32 and 128 kilobytes. So in best case, you can have like 64 kilobytes for CNC and data. And you can also do OS fingerprinting, just like recon operation inside someone else's air-gapped network, because there are some papers that are describing how can OS and the machine where you connect your USB device can be fingerprinted, so that device can kind of know what kind of OS you're running and what hardware. So this might be possible with this system too. And Evil Charger works basically on the same principle. So imagine two machines sharing the same charger, one of them being air-gapped, but of course both of them have to be infected by other means, but we are just talking about exfiltration and CNC. So in this case, you can basically, with this charger, achieve the same effect. And in case you want to do some research, I found a very interesting website that I want to point you to, so that you don't have to buy like 50 chargers and open them and spend a whole bunch of money. It's called Chongdiantou. It's really amazing. It's like it's really amazing. I mean, I want to if there was a subscription, I would definitely pay a subscription for this website. So basically, they open these chargers for you, and they tell you what kind of chips are inside, and yeah. It saves a lot of time in the early research phase. So
you send it to them, or
no, you just find that on there. They have like blog style web page. I fix it on steroids, I would say. So yeah, and in the end, how about HDMI dongles? So usually if you have an HDMI dongle, or this is not HDMI, this is just DisplayPort. Okay, it has HDMI, but dongle like this. So this is, as far as I can see, DisplayPort, or yeah, mini DisplayPort. And if you have a plug like this, it's not smart in a way that that you can do lots of stuff to it and write to and like you have just display lines and some other. It usually serves as an output device, but in this case, this device provides by the standard it has to provide so-called billboard device interface. So in case this alternate mode is not triggered, it has to send some information, some debug data to the host. So how can we abuse this? Well, through if some chips that are placed in these dongles. So basically, you have these D plus and D minus lines. These chips can these chips speak USB 2.0. So when you connect it to a computer like mine that doesn't have USB Type-C input, you can basically see that it shows up as a billboard device. And apparently, I was lucky. The one that I ordered from Amazon just came with a firmware that was just unaltered example from the chip manufacturer. So basically, I just went to the chip manufacturer's website, downloaded the software and software development kit, and I had the complete source code that was running on the dongle. So I was able to actually alter the firmware, and because you can do basically anything with firmware, I was able to actually alter the firmware and change just to demonstrate, to change the vendor ID and product ID. And this is just to I want this device to maintain the software firmware upgrade functionality. So I didn't mess around much more with it. But actually, I could basically just by using these two lines, the green lines, I can gain control over these other four channels that are used for communicating with Type-C hosts. One of them being CC lines, so I could just pretend to be a cable, pretend to be anything. So contrary to bad USB, which is really amazing work by my friends and former colleagues Jakob, Sasha, and Karsten, this can be called, like, contrary to if USB 2.0 was bad USB, then USB 3.1 can be called probably like worse USB. And let's see what can be countermeasures. So basically, one countermeasure, you can put super glue in the USB port, but that won't work if you use a Mac, because that's your only port. And you can disable firmware upgrade. Yes, but what happens if there is a bug in your firmware and the manufacturer wants to upgrade the firmware on your device? Then, of course, the trivial method that was mentioned thousands times already is firmware signing, and that's already inside the Type-C power delivery firmware upgrade specification. They mention that that manufacturers should sign their firmware using decent crypto methods, but they don't specify crypto methods. They don't specify firmware upgrade methods, safe firmware upgrade methods. They just have a recommendation. And there is also a Type-C authentication specification, which is meant to authenticate so the devices authenticate to each other. That was meant to be also an interesting countermeasure against these kind of attacks, but I have to read what is literally written in the specification. Products should provide protected, tamper-resistant operation and storage for the private keys to prevent them from being read, copied, or otherwise disclosed. I mean, can you imagine tamper-resistant devices that are cheap? And it just leads to a whole new set of problems. And I think that these kind of things will not be properly addressed in the near future. And in the meantime, this probably can and will be exploited for bridging the air gap. So just to sum up everything, USB is definitely used more often than other means for bridging the air gap. And with USB Type-C, the game becomes much more interesting, cheap and everything. And proposed countermeasures will be really hard to implement on a large scale, and if ever. And in the meantime, you can use the old methods like glue. Okay, thanks. Any questions? Yeah.
Please wait for the microphone.
Thank you for the presentation. Do you think that the recent Blueborn thing can be put in one of these sections?
Yeah, of course. I was aware about that before the presentation, and of course it can. But then, if you go into that direction, then you can also put Broadpawn and others. So I wanted kind of to guide this presentation towards this. Thanks.
When you change those device IDs in the driver, does it show on, let's say, Linux, dmessage, or LS USB or whatever?
Yeah, of course. It shows the device ID and vendor ID, but it's a custom vendor ID, and I made sure that I don't put some that was one of these vendor IDs that was already used by some company. So.
Okay, thank you.
More questions?
Question? One question here.
I recommend epoxy instead of glue.
Yeah, it's a good alternative. Okay. One more.
What about mobile phones that ship with USB-C? Because C practically only does specify the physical connector and not the protocol that actually speaks on the host behind it. Would that work to infect phones as well?
Yeah, that's an interesting question. Thanks for mentioning that. So if we go back to this charger, this one, the one in the lower right, as you can see, it's standard USB-A plug, but not really standard. So it's for this family of phones that, like for the phone that I have, it has USB Type-C connector. But in this case, this charger, for example, uses kind of non-standard way of communicating with the phone. So it doesn't use CC lines for communication, but it uses actually D+ and D-. So it basically uses USB data lines, and over these data lines, it talks synchronous serial communication. So basically, it's kind of a weird way of communicating. It's something that looks like I2C. And that can also be, of course, I checked that there is a firmware upgrade mechanism for these chargers, and apparently they don't sign that, so that you can kind of, if you infect one of these smartphones, you can also infect firmware upgrade, and you can also infect these kind of chargers. So it can work. It just takes some research.
So basically never lend a charger to anyone.
Yeah, or you might end up even with ransomware on your charger. So, okay. Any other questions? Yeah.
When you change the ID of the device, is there a possibility to roll it back?
Yeah, of course. I saved the.
No, you flash it.
Yep.
Is it somewhere saved on some ROM or other?
Well, of course, there is this dual banking, so I change it only in one firmware bank, so I can always revert to it.
You can roll it back, so I can read the real hardware ID from that chip, from that device.
Yeah, of course.
Okay,
So
thank you.
you just you don't even have to have a host that actually speaks Type-C. So in my case, I just have this adapter. And okay, any other question? Yeah.
When you said there's another firmware in another slot, can you read both firmwares from at the same time to compare them?
Yeah, of course.
To find tampering?
Yeah, of course.
I mean, nobody's going to do that, but
Yeah,
In,
no.
in theory, it's possible.
Yeah, of course, of course. Any other questions? Okay. Thank you very much.
Thank you, Mark.